In lesson 4.6, we're going to talk about isosceles and equilateral triangles. And I have a picture of an isosceles triangle right here. An isosceles triangle has two congruent sides. The parts of an isosceles triangle have special names. And those are that the congruent sides are the legs of the triangle. So here's my congruent sides. And the third side is called the base of the triangle. So my congruent parts are my sides are my legs, and the third side is the base. The angles between the two legs is called my vertex angle, and that's angle 1 here. And the angles opposite the legs of the triangle, so in this case, angle 3 and angle 2 are called the base angles. And we have a theorem for isosceles triangle. It says that if two sides of a triangle are congruent, so in our first figure, triangle ABC, we have two congruent sides, then the angles opposite those sides are congruent. So our opposite angles are angle 1 and angle 2, so they have to be congruent as well. So if our legs are congruent, the base angles are congruent. The converse of that starts with the angles. If we have base angles that are congruent, then the sides opposite those angles must also be congruent to each other. I have an example. Example 1, congruent segments and angles. Name 2 unmarked congruent angles. So I can confirm that I have congruent angles if I have legs that are congruent. So for part A, I see that in this triangle, triangle ABC, it has congruent legs, so its base angles must also be congruent. That tells me that angle B has to be congruent to angle ACB. In part B, it said name 2 unmarked congruent segments. So I know that in an isosceles triangle, if I have base angles that are congruent, then I have sides opposite those are also congruent. Triangle ADC has base angles that are congruent, so the sides opposite those would also be congruent. So that segment AD is congruent to segment AC. An equilateral triangle has three congruent sides and 3 congruent angles. It also fits the same criteria as an isosceles triangle. So those rules would apply here as well. But we know that an equilateral triangle, a triangle is equilateral if and only if it is equiangular. That means that if I have all 3 angles that are congruent, then my 3 sides have to be congruent to each other as well. And the reverse is true. If I have 3 sides that are congruent, then I know that my 3 angles would also have to be congruent. So it's going both ways. 4.4 says each angle of an equilateral triangle measures 60 degrees. So we know that all of the angles of an equilateral triangle are congruent. And so if one is 60, then they all have to be 60 degrees. That's because there are 180 degrees in a triangle, and 3 congruent sides, 180 is divided by 3 is 60 degrees. So each angle is 60. Then we've got a couple of problems where we're going to find some missing measurements. Find each measure. And so for the first one, we have our triangle XYZ. we want to find the measure of angle y. I know a couple of things about this. I know that I have two congruent sides, so those are going to be, we could call those the legs of our triangle. And if this were isosceles, or equilateral even, if I have two congruent sides, the angles opposite those guys are congruent. So that means that z and y would have to be congruent to each other. I know that I have one angle that's 60 degrees. So I know that the measure of angle y plus the measure of angle z has to equal, or plus 60, sorry, equals 180. So that means the measure of angle y plus the measure of angle z would equal 120 degrees. Well, since y and z are congruent, they have the same measure, I would just take 120 divided by 2 is 60 degrees. So y and z both would have to be 60 degrees. And then the last example, I have I guess it's the second example there, sorry. I have another triangle, PNM, and we want to know the length of PN. We want to know what this guy is. Well, I have congruent base angles here. And the converse of the isosceles triangle theorem says that if my base angles are congruent, then the sides opposite those are also congruent. So that means that PN must be congruent to MN. And MN is equal to 11 centimeters. So PN also has to be 11 centimeters. And example 3, this very last one, we want to find a missing value. It says find the value of each variable. Some things that we know about the congruence markings is that AC and AB are congruent, which means that their base angles, the angles opposite those, also have to be congruent to each other. So that means that if angle B is equal to 2x, then angle C has to be equal to 2x. And that means that all of our angles are equal. Well, if all of our angles are equal, then that has to be an equilateral triangle. And we know that the angles of an equilateral triangle are 60 degrees. Each one is 60. So that means that 2x must equal 60 degrees. And if I divide by 2, I get x equals 30 degrees. I also have a y there, and again we said that it's an equilateral triangle. So if it's equal angular, that means if all the angles are equal, then all the sides are equal. And I know one of the sides is 3 inches. So that means that AB would have to be congruent to BC. And so my 3-inch side would equal 4y minus 5, and I'm going to solve for y. If I add 5, that's giving me 8, and divide by 4, I get y equals 2. Okay, that is your set of notes, and you have practice 4-6 to work on.